Question 1. Okay, the figure shows three resistors R1, R2 and R3 connected to a power supply. To get your power supply, R1, R2, R3. Okay, so it's talking about the current in R2, multi-choice. So here, the current in R2 will always be less than the current in R1. Well, yeah, because the current that goes through here splits. The current going through here splits. Some goes that way, some goes that way. So R2 will always be less than R1. Okay. Less than the current in R3? Well, not necessarily. Depends on the values of the resistance. The same as the current in R3? Well, it might be, but that would mean that those two had to be the same resistors. The same as the current in R1? No, because some current has to go through R3. So, yeah, it has to be A. It's always less than the current in R1. Okay, part B. Diagram. And you can see on the diagram you've got a power supply, you've got an 82 ohm resistor and a variable resistor. So the potential difference across the 82 ohm resistor is 6 volts. Calculate the current in the circuit. Okay, so it's a calculate question. Okay, so if it's calculate, what do we need to know? We've got the potential difference, we've got the current, the resistance, we need to know the current. So we've got the equation V equals I R. Okay, so if you want to work out the current, you could either have it as a triangle or rearrange the formula. So I want to work out the current, cover up the I, and I've got V over R. I equals V over R. So 6 volts divided by 82. Okay, you need to make sure you get the numbers in the right order, and you can clearly say 6 divided by 82, that equals 0.073. Okay. Part 2. Describe how a student could add meters to the circuit so that the current in the 82 ohm resistor and the potential difference across the 82 ohm resistor can be measured. You may like to draw a new circuit diagram to help you with your answer. Okay, so this is a describe. So, sketch. Do we have to do this mega accurate? Well, if you've got a pencil and a ruler, you should use them. Some examiners will take a dim view, so you will need to add to the circuit an ammeter and a voltmeter. So the voltmeter always has to be connected in parallel to the resistor, and the ammeter has to be in series. Now that could be anywhere around the circuit. Okay, so what I'm looking for is connect a voltmeter in parallel with the 82 ohm resistor and connect an ammeter in series. Okay, and the last part of the question. Okay, so you've got two resistors. This question was answered quite well by some people. It says the current is 0.03 amps, and it's a calculate question again. Okay, so in order to do this, we need to work out the potential difference across both. Okay, there's two ways of doing it. We know the current here is 0.030 amps. So that current's going to go through both, and we know V equals I times R. So we can work out the potential difference across each and just add them up. Or you can work out the combined resistance of both using the formula R equals R1 plus R2, if you can remember that. So, potential difference across here, V equals IR, it's going to equal 0.030 times 68. And then we've got across the other one, let's put those in the calculator. And that's 2.04 volts. And we'll call this V2. I'll call it V1. And V2 equals I times R equals 0.030 times by the resistance, which is 56. .68 volts. So the potential difference across V1 plus V2 is equal to 2.04 plus 1.68 equals 3.72. 3.72 in the space.